Consider the unbalanced half reaction for the conversion of chlorous acid into diatomic chlorine molecules in acetic solution. When this half reaction is balanced using the smallest set of whole number coefficients, what is the coefficient of hydrogen ions and how many electrons are involved? To balance a half reaction in acetic solution, we do the following. Step 1. First balance all elements besides hydrogen and oxygen. In the case we have here, the only element involved besides hydrogen and oxygen is chlorine. As currently written, we have one chlorine atom on the left, and we have two chlorine atoms on the right. Balancing chlorine is a simple matter of changing the coefficient of chlorous acid to 2. The next step is to balance hydrogen and oxygen. It is best to balance oxygen first. To the side that is deficient in oxygen, we simply add one H2O for each missing oxygen. Then to the side that is deficient in hydrogen, we add hydrogen ions, one hydrogen ion for each missing hydrogen. Let's look at the case we have here. On the left, we have 4 oxygen atoms. On the right, we have no oxygen atoms. We have 4 XX oxygens on the left. Therefore, the right side needs 4 oxygen atoms. To balance oxygen, we simply add 4 waters to the right. Now, oxygen is balanced. Next, we balance hydrogen. The left side has 2 hydrogens, but the right side has 8 hydrogens. So, to balance the hydrogens, we add 6 hydrogen ions to the left. Once we have balanced the atoms, the next step is to balance the charges. The total charge on both sides must be made equal by adding electrons. Add electrons to the more positive or the less negative side. Let's look at the case we have here. The charge on the left is plus 6. Each hydrogen ion has a charge of plus 1, and there are 6 hydrogen ions on the left. 6 times plus 1 is plus 6. The chlorous acid molecule, HClO2, is neutral, so the total charge on the left is plus 6. On the right side, the total charge is 0. A diatomic chlorine molecule is neutral. That means it has a 0 charge. A water molecule is also neutral, so 4 water molecules have a total charge of 0. 4 times 0 equals 0. We can see that the left side is more positive. Its total charge is plus 6. At this point then, we say that our half reaction is not yet balanced. To balance it, we add electrons. We need to add 6 electrons to the left side. Remember that each electron carries a -1 charge. So now the total charge on the left is 6 plus -6, or 0. Both sides now have the same total charge. Therefore, the correct answer choice is C. The coefficient of hydrogen ions is 6, and the number of electrons involved is 6. A couple of comments. The half reaction we have here is a reduction half reaction. Reduction involves a gain of electrons, and electrons will appear on the left-hand side, as in this case. Good memory aid for this is the acronym REGAL. In reduction, electrons are gained and they appear on the left-hand side of the balanced half reaction. Conversely, if we find the electron on the right-hand side, we have an oxidation half reaction. Oxidation involves a loss of electrons. In reduction, we expect to see a decrease in oxidation number. The total change must be the same as the number of electrons in the balanced half reaction. If we assign oxidation numbers to the elements involved here, we find that chlorine has an oxidation number of plus 3 in chlorous acid, and it has an oxidation number of 0 in diatomic chlorine molecule. Therefore, we find that the oxidation number of chlorine decreases by 3 for each chlorine atom that is involved. Since there are 2 chlorine atoms in each diatomic chlorine molecule, the total oxidation number change is 6. This is, in fact, an alternative way of determining the number of electrons required to balance the half reaction. You may see this method in some textbooks. One final comment. In case your teacher requires that you use hydronium ion, H3O+, instead of hydrogen ions when balancing half reactions in acetic solutions. In this case, all you have to do is replace each hydrogen ion by a hydronium ion, then add an equal number of water molecules to the other side. In the case we have here, we replace 6 hydrogen ions on the left by 6 hydronium ions. Then add 6 more water molecules to the other side. So instead of 4 water molecules, we now have a total of 10 water molecules on the right side.